This is question number 8 out of your notes, limiting reactants. This will probably just be letter A on there. But so remember, a limiting reactant means one reactant's going to run out before the other one. So one reactant's in excess, one is limiting. So in this case, I have your two reactants here. I'm going to tell you this is an easier problem because it only has one product. It's always a little bit tougher when there's two products, but still very similar. Anytime I give you both reactants, if I give you masses of both reactants or moles of both reactants, check and make sure that one of them is going to run out first probably. Okay, so it's probably limiting reactant. You'll see a lot of limiting reactant problems throughout the year. Last year in general chemistry, a lot of times we solved limiting reactant problems by taking this reactant, going to the product, taking this reactant, going to the product. And remember, whichever one produced the lesser amount of product was the limiting reactant. We can do it that way. I think it's a little more time consuming, so I'm going to do it a little different way right now. So in this case, it's saying if we have 200 grams of that S8 and 100 grams of Cl2, it wants to know which one's going to run out first. And then it's going to ask how much product is produced, I think, is the other question. So what I have done here is taken my 200 grams of S8 and turned it into moles. So 256 grams is 1 mole, so we have 0.78 moles. So 200 grams is 0.78 moles. I did the same thing with chlorine, turned it into moles. Okay. Looking at the equation here, it's a 1 to 4 ratio. We need to have 4 times as much chlorine as sulfur. So chlorine needs to be 4 times bigger. If it's not 4 times bigger, it's going to run out first. If there's more than 4 times as much chlorine in terms of moles, remember not in terms of grams, in terms of moles, if there's more than 4 times as much chlorine, then they would be in excess. Well, we can kind of just estimate here. 1.4 is about double that. If we wanted to divide this by 0.78, we could see how many times bigger it actually is. It's about 1.8, but this is about double that, and it needs to be 4 times bigger than that. So I know this is not 4 times bigger. That tells me then that this is my limiting reactant. So this is my limiting reactant. There's going to be excess of the S8 that will not be reacted because we're going to run out of chlorine atoms or molecules to react with it. So here's the first thing. We figured out the limiting reactant. So next question is, what mass of this would be produced in the reaction? So whenever you're doing stoichiometry, never start with your thing in excess. If you do that, you're going to get too much of the other things. So start with your limiting and work to that. And I could start with grams or with moles. It's going to be faster to start with moles. So I'll say we have 1.41 moles of chlorine. Mole ratio is 4 to 4. For every 4 moles of chlorine, there's 4 moles disulfur dichloride. And then a mole of S2Cl2 is however many grams. That is 135 grams per mole. So we get about 190. 190.3 grams of S2Cl2. The other question asked, so we know this is 190. The other question I'll ask you a lot is, how many grams of the excess are left over? So we know this is limiting, so there's none of that left. All the chlorine will react off. There's some of this left. Well, for a problem like this where there's only one product, it's pretty easy to figure out. If this is 190 grams, and all 100 grams of that were used, that means that 90.3 grams of this had to be used. So this had to be 90.3 used, so 200 grams available minus 90.3 grams that's used. We can get our answer from there. So 109.7 grams of excess. And that's the sulfur. Now, if there would have been multiple products, we could not do that. So what we would have had to do then is go from our limiting, do stoichiometry, starting with the 100 grams of chlorine, because we know all that's going to be used, do stoichiometry to S8 grams. Work our way to that and figure out how many grams were used. You would have figured out that 90.3 grams were used, subtract from how much was available. I will do letter C in a different video.